My name is Schaub. I'm heading the quality management at Winergy. Winergy is for the one who don't know Winergy or Flender, Winergy is the business segment of Flender, delivering component system services to wind turbines, starting with gearboxes, coming to couplings, generators, to complete powertrains. Yeah, I'm very excited and happy to be here to present you how a common language, a common understanding leads to a shared responsibility and at the end leads to increased reliability and reduced failure costs. And we heard at some point in other speeches already how determining these things are in our industry. And we already heard today, the world around us is changing. It is dramatically changing. We see rapid scaling of wind industry, of wind turbines. We see as well that energy security becomes a strategic lever and a political lever. We don't know how many energy crises we will see in future. Nobody can tell us. And we have a quite complex world with global supply chains and rising expectations for reliability and cost control. So these factors and these environments, these boundary conditions make the alignment in between the OEM and supplier not just helpful, it can be or it will be a decisive factor being successful in the industry. There are some further specific challenges for the wind business. We have greater mechanical complexity if you compare it, for example, to solar business. We have at the moment quite high requirements and increasing requirements for increased power ratings, for increased power density of single components, and as well high requirements for lower noise emissions, so that turbines can be placed wherever we want it to be, so that no one is disturbed by noise emissions. But some things don't change. Cost for field interventions are high, they will stay high, and longer globally supply chains will be present as well in the next years and in the coming future. So that means reliability, having these factors in mind, is a decisive competitive edge. The reliability is key to be successful. But the question is, how can we increase, how can reliability grow? And it can be grown when OEMs and suppliers collectively commit to that we have a combined common understanding of requirements, how to read that, how to speak about them, how to determine feasibility, how to rate feasibility, make transparent risk assessment, make risk visible, and create stable processes. So the key for being successful in this industry is that the OEM and the supplier find the right language, finds the right understanding that we are talking about, and this is a key success factor. Being successful without the right understanding, the success is being in question. But finding the right understanding, finding the right language has as well some challenges, because we have here different stakeholders in the room. We have project developers, we have utility drivers, we have OEMs, we have suppliers, and everybody of you has a certain expertise that is somewhere put in a guideline, in a requirement specification or wherever. And we know that information is generated at different stages in different contexts, and these informations don't always align in timing, in interpretation, and therefore there is a risk that that things are not understood well. Therefore, we need to have a clear foundation so that we understand each other and that we allow to grow and to work on increased reliability together. How can that be done? Early requirements choices drive financial performance. The earlier the decisions are taken, the bigger the impact is. We know that. We know as well that late requirement decisions will be costly. At the end, the best way is to have clear requirements, to take them at the right point of time, and that they are understood well. So that will reduce design loops, will decrease costs, and will assure that decisions are taken at the right point of time. At the end, no one of us likes risk in this room. We know risks are present, and we have right tools to cope risks, but at the end we don't like them. Especially we don't like the risks that we are not knowing. The unknown risks, these are the ones that we don't like especially. So how do we come to a perspective where we have all risks visible, where we have all risks in mind, and that we are identifying the risks at the right point of time? Seeing our products, seeing things in a system context is a key for identifying all risks. Especially with the further growing of our industry, the further growing of products, power ratings, requirements, the risk might be hidden in interfaces. So these, and that is a complex thing, these might not be completely understood in prototype testing. Often, these risks will just become present and visible in the field when prototypes or with first series will be running in the field. So looking at the system makes the load passes more visible, makes constraints visible and real conditions. So the earlier we look on the product on a system context, the earlier we have the chance to identify the complete picture and the complete potential list of risks. And there are certain things that we are quite well aware of. So we know that we have materials, and materials always are coming with material variability. We strive for uniform quality, for uniform standards, but within these standards, a certain variability is given. We will have tolerances and interface fits, and coming to increased power density, our engineers, our design departments, they will strive for reducing these tolerances and these interface fits. There's no other way around. We need to bring more power over lower weight. Therefore, this is quite an important point. And of course, we have the tools on hand to look at process capability and repeatability. At the end, of course, there's certain variability and given by operators, but here as well, we have tools in mind and tools in place for standardizing, and there we can minimize risk, we can mitigate risks. So, but the crucial things coming from the system perspective, looking at system engineering, from the design perspective, looking at component design, is that we connect these layers together. If we connect these layers and think in a system approach, risk mitigation becomes cohesive, and we must step away back from thinking in silos, taking mitigation actions in silos in certain boundary conditions, to looking at the system condition and addressing risks on always starting from the upper perspective, seeing the system, not just the single components, but as well how they interact in a system with their interfaces. Coming now to the output of what we are doing here. So looking at the requirements, understand the requirements, working right together, align each other, increasing the reliability of the product, taking care for an energy security that we want to have based on high reliability. That will lead at the end that failure costs will go down. Increased reliability should go along with reduced failure costs, meaning our industry will be more successful, because at the end it counts. Investors are looking at figures. They want to see successful companies that bring money at the bottom line. So, and we know that is built in the wind industry. Whenever a failure occurs, it is costly. So our products are 100 meters in the height, especially they are getting costly if they are offshore. We need to take care for replacement costs, crane mobilization, and especially, and under the aspect of energy security, the costs by lost production are potentially the most crucial ones. And here, with the APQP4Wind framework, we have the right tools in place so that we can address the right mechanisms to make a clear path from bringing the requirements understood at the right place, having the feasibility validation in place, making risk transparent, and finding the right mitigation actions for risks that are identified. And at the end, this should lead to a better cost position, decreased failure costs, and more successful wind industries. So seeing that from the overall perspective, how the APQP4Wind framework can contribute, can support what we have as requirements coming from the market. So first thing, as mentioned, we in a partnering environment in between OEM and supplier, we need to find the common language, the right understanding. So that we are able to faster onboard suppliers, faster onboard new products, new processes, and get to a more consistent quality. And here as well, supply chain resilience is of importance, that we have as well in quite volatile times, supply chains that are working are resilient against disturbances. APQP4Wind is more than just a standard, it should become a culture. So a culture where expectations are transparent, where risks are shared, and risks are transparent because the known risk can be mitigated, insights flow freely, and then the success is collective for the complete industry. And yeah, it's really great for me to speak in that group of leaders in front of me, because you have a key role here. In your organizations, you need to support this culture of APQP4Wind clearly, definitely, without any doubts. So then we get to a structured feasibility in the organizations, in the collaboration in between us, and we have open risk discussions. And that is of high importance. Discussing risk openly, not hiding them anywhere, discuss risk openly as soon as they are identified. And we all have field experience that is valuable. So we need to have as well the right tools in place, the right processes to capture experiences, valuing fields experiences, and bringing them to the right point of time to taking the right decisions for design, for process, for better products. At the end, this will end up in a cross-functional collaboration. So we are not in need just to talk within our quality departments. We need to work cross-functional in the supply chain, with the design department, with the service departments, with the management. This is a teamwork, this is a collaborative work, and then we will be successful. At the end, that will get to a situation where we have that common language, we understand each other clearly. That language will tell us the right things without losing information aside. We get to shared responsibilities, and we then get to more competitiveness due to higher reliabilities in this field, lower field failure costs. That leads at the end to more successful companies at the bottom line, supporting the energy transition and energy safety wherever it is needed. Thank you. I'm open for your questions.
Thank you very much. Very interesting. So, any questions? We have a mic here.
Thank you for a very nice presentation.
Thank you.
I mean, reliability, I've been there for close to 40 years. And you're the first one really mentioned what the standard is demanding. But I have two comments to that, because standard will not give you the right product. And if the designer initial specification is not fully understand, then probably you have to do it in the second time when you come to the test level. And that is the main problem I've seen between a lot of different companies. But we are going the way you are showing here, then we are on the way, but the fundamentals should also be okay. Yeah. Thank you.
Yeah, thank you. I think very well comment. If we look at our designers, or it probably will be the same here in the room, and talking about specification and how experiences are captured, they can be captured in in 3 specifications, each 10 pages, or they can be captured in 30 specifications with 50 pages. Nothing is right, nothing is wrong. The important thing is that the people that are working together are understanding the meaning within and maybe in between the lines. Therefore, capturing requirements, design goals according to the APQP4Wind standard, and these are giving really right tools, approaches, understanding the customer voice, just having us some buzzwords, important buzzwords. I think these are the key things that are to be respected by the designers designing the product at the end. It's not just reading the specification, it's as well understanding that, getting in contact with the one who has created the requirement.
Yeah, and then maybe it's also a little bit about executive processes, right? That sometimes you need to make mistakes in order for you to learn the next time, right? And then, but just one reflection, sorry about that. One reflection, seems like that you have a strong implementation of APQP in your organization. What was the most difficult part about implementing APQP?
It always, to be honest, it always can be better. So it always, of course, it is easy to convince someone in quality of APQP4Wind and telling, hey, this is an established standard, not just in wind, having history in automotive and so on. I think most important and most hurdles are leaving behind things that have been done different in the past. So convincing people, and it's a change process, and explaining why different standards, new standards are needful, what are the benefits, and what can be kept from old standards or what are similar, but what should we leave out because it's no benefit anymore. It's in fact a change process, convincing the people, talking with the people, and taking them with us in that change management process.
Yeah. And then continuation and repetition. And
training.
Yeah.
Conversation, communication, and repetition.
Yeah. So if there's some of the companies in the room that have just started implementing the framework, what's your recommendation in relation to how to make the stickiness and continuation? What would be the next step for them to?
Training, determining some key persons internally. I think it's crucial to have certain key experts within an organization, and then as well make them as internal trainers in the organization. Of course, there are good external trainers as well in the market, but I think making, especially the change process, you need to have internal people who knows insight into the standard, but as well can transfer them and take the people on that journey from old standards, old processes to new ones.
Good, thank you. Any questions? Yeah.
I see you put leaders and play a key role as I see that's an enabler as well. How do you see the challenge to convince them, the top management of the company, to implement APQP4Wind and really commit to it?
The easiest way for leaders managing an organization is, of course, figures. So, and if you can convince leadership, hey, working on these topics will definitely lead to reduced failure costs, will lead to bottom line better business results, is the easiest convincing factor. That is the one thing. On the other hand, the customers, the OEMs, our OEMs are driving that topic and they are requiring that. And this is not just something that happens here in Europe. So this is a topic that is globally pushed from the OEM, in this case from the OEMs to us as supplier. And that, of course, is convincing the management as well, flowing these requirements down in the organization. I think these are the most important things. It is visible that these standards reduce failure costs, increase reliability, and so improving the business success. And on the other hand, if customers are requiring that and pushing for that and showing, hey, our costs for non-production are far too high, and you can support us to make that transformation to a more resilient energy producer, that is as well a big factor convincing leadership for supporting these standards in the organization.